Hey gang, I've been thinking about making some sort of task light, I think for 8 years. It's on a post-it note that I have in my office at home. I finally found the missing ingredient, and that is this par 30. It's basically a floodlight bulb. Once I got these samples and tried them out, I was like, oh my gosh, I am putting this on a task light. I have just got some 16 gauge wire and an arbitrary length of lock line I think is going to be about right. So let's put together a task light. I need the right amount of wire. Better to have too much than too little. This is janky, but this is a prototype. I'm just gonna solder these two wires onto the end of here. Always flux. So I'm just gonna solder straight here. I'm not gonna heat shrink it or anything. I know this is bad electrical practice, and you should never do this at home because you always want your wires to be insulated and separated. This is just a quick knock together prototype, so I'm not gonna worry about it. My goal in doing this was to get something that is functional as quickly as possible. So I really did not pay any attention to things like cosmetics. And that's really the way good design process works, is that it is iterative. When you have questions, you can spend a lot of time thinking about it, but I find really the best thing to do is actually try it, test it out, make a prototype, make some mistakes, learn some lessons, and then move on to the second version. So we got our parts cleaned up close enough for what we're doing here today. So one of the things I got are some cord grips for the cord to exit. On the prototype, I literally just punched a hole in the side, which worked, and I made the hole tight, so there is some tension on this, but you could literally just rip this cord out if you wanted to, and that's bad. So I printed a little flat inside here to give this nut a flat area to seat against. Look at that, dead flush. Just like the model told me it was going to be. This is not hitting the bottom when it rotates, and the flat is wide enough that the nut isn't hitting the slope sides. This part is basically based on a 3D model of these lockline segments that I downloaded from their website, which is awesome that they provide that. So basically when I attached this first part on, I realized I didn't want this first segment to be able to move. I wanted all the motion to happen in the actual lock line. So I made this little collar. It's like a split collar just to test the dimensions. And so there's a tiny bit of play in there, but I also wanted this to be able to seat down all the way. So I used this collar to test the correct height. I added in a little ledge that should be exactly at the same height. So check this out. 2 threaded parts. I have not actually tried to thread them together yet, so oh man, it's a little tight, but that is absolutely perfect. This is basically just a standard 2-wire, single pole, single throw toggle switch. There's a little flat, but I made a notch. Can you see the notch? Basically to hold the side of the switch and keep it from rotating once it's installed. So let's see if that's even gonna work. I was gonna go through. Oh, well, okay, so the problem I was having inserting this is this is hitting that little stud in there, but if I just turn it sideways, I can slide that in and then rotate it into position, and it just fits right in there. Again, this is all based off the model. Toggle switch, so that's cool. And then that cord is gonna go in there, cord grip goes on, pinches down, and so we're going to be doing something roughly like that. I wasn't going to do this, but I'm going to do it. I'm going to tear this one apart and just swap the new pieces in, because that's going to be faster, and I'm into fast at the moment, so let's do that. One of these is going to get a spade. This one is going to get wire nutted, so I need that a little longer. Okay, that seems reasonable. Ready? Put that magnet back in there. The other magnet that I was using was 60 pounds. This one's rated at 127 pounds. You want to be careful what you stick this to. It's probably going to need a nut for the real show, but oh man, look at that. That is definitely smoother looking. So this is really the part I need to work on next. This geometry is good. I actually bought some different sockets that are going to allow me to make this more compact. I literally just had these. And then this piece is, I think, also going to shroud this area a little bit and cover that up. So when you adjust it, you can kind of grab onto this section and move the whole thing around. You really don't want to be pushing on the bulb part while you're adjusting it. This little black ring just turns. So wide, over, yeah, that's good. Wide, narrow. Wide, narrow. Should we go try to stick this to something and see how that magnet does? I think we should. That's a good spot. I think the magnet's going to be strong enough. There's that rubber boot under it, which is going to lower that a little bit, but the other magnet I was using, was not very stable on a vertical surface like this. First thing I need to do is buy a few magnets and test fit them. I would like it to be a little bit less proud. It's actually not bad, but it's definitely torquing a little bit. It also seems like maybe that threaded area where I've used a 3D printed material to thread that post in is actually, in its current configuration, not rigid enough, because it feels like that magnet's actually moving in there. This printer is also capable of laying in carbon fiber inside of the plastic. That would definitely take care of the strength problem. It's just slightly more challenging to print. I'm also going to try to reduce this gap a little bit, just so there's less room for the magnet to move around. This is pretty sweet. I'm excited about it. I hope this is going to be really useful for you guys. So I'm going to go get back to work on version 3.